This is the second video on Omni Synchronous API. In this video, we are going to discuss some technical details about Synchronous API. In my last video, I showed you how to use SLE4442 card using Synchronous API. In this video, you're going to see all the technical stuff, what exactly is going on in the background. So we're going to understand the various methods used in the API, and we're going to discuss the methods that are used for SLE4442 and SLE5542 memory cards. The Synchronous API is also used to read and write to SLE4428 and a few types of I2C memory cards, and also some of the memory cards from Atmel. So this video will be helpful for software developers and students of technology. So I'm assuming that you have already downloaded the Sync API version 3 from Omni website. We're going to see what is in the folder once you install the Sync API. You have to read the Sync API documentation a couple of times. We look at a sample VB project. So this is a very interesting project for developers. You can take this as a starting point and start understanding the Sync API for various other cards as well. In my first video, I was using the Omni 3021. This was one of the cheapest reader writer you can buy. So this is a contact reader writer. Whereas in this video, I'll be using Omni 5422 reader writer. So this is both contact as well as the contactless. So we're going to see that Synchronous API also works with the OK5422. So one thing I would like to mention here is 5422 is the recent reader writers. It's not the latest one, but this is one of the new reader writers, and you don't have to use Synchronous API if you are using this reader writer, because this reader writer also supports a very high level commands called APDU, so you can use them. So after you install the Sync API version 3 on your laptop, so it creates a number of folders, and the software automatically registers the DLL into your PC. Now if you go to this your C drive program files and go to HID global, you should see a folder called Sync API version 3. Now here in the first folder is help, so you got a PDF here. This is the one you have to be reading again and again. This is called Sync API Software Developers Guide. Now this is the document I'll be going through with a couple of methods. And some of the, if you see, there are in this include folder, so you got the C header files. So I don't see anything useful in these header files. You can go and peek into that and see some of the constants defined there, but these are all a proper C functions. You go to lib folder, and the sample folder is here. So again, here most of these programs on the top, these are written in C or C++, and if you want to do any .NET programming, you can look at this VB sample. So the most important thing here to learn is, so look at this file called scard.vb. Now in here you will find the functions. Okay, these are the function that belongs to the Win smart card DLL, and this is how you'll end up accessing your smart card. So you can just copy paste and use this thing. So you can come across all these predefined errors and error names. You can use them as well. So after that, you have to look into this SCARD2WBP. So SLE4442 is a 2-wire memory card, and this one, the SLE4428, so that's a 3-wire memory card. So open this. So this is where you see all the declarations to access the functions in the DLL. Now all the functions you need to read and write are available here. You can just use this module as it is, it will work. That's what we have done. So this is the function. You got function called scard2wbp read data. Now if you look at this, I'm just going to explain one or two declarations so you'll understand all the rest. See, this is the name of the method in the DLL. The name of the DLL is scard sync. So this is a 32-bit DLL, and this is a 64-bit DLL. So however, as I mentioned before, I could not get the software running with the 64-bit DLL. So I'm not sure why, but it doesn't matter whether it's a 64-bit or a 32-bit, it works. So here again, the name of the API, the method name is the same thing as scard2wp read data 64, and this is present in the library called scard sync x64.dll. and again, this an alias here which refers back to the same function. So you got a function for read. So to know all the functions that are related to SLE4442, so you have to read this using 2WBP cards and scard with overview. So these are all the functions that are available to access a 2-wire memory card like SLE4442. So you got a function to read the data, read the protection memory, write the data, compare and protect, and present the pin, and change the password or pin, and check if the pin is already presented to the card. And if you click each of these functions, if you look at here, now you just have, if you're coming from a .NET programming background, you might struggle to find the correct data type for this, but once you know what they are, so the best thing to understand is if you go through these samples. Sorry, I forgot to mention, so there is a form here. In fact, you can run this project. So here there is a form. Yeah, you can run this. You can run this sample program. This software runs. In fact, it runs. Okay. So using this, I might have made a video a few years ago explaining how this screen works. So it's worth going through, opening this entire VB project in a Visual Studio and see what they have done. The codings are not the modern coding I would that's what I felt. So this must be now coded maybe tens of years ago. Now if you look at here, in order to read the data from the card, you will be calling this function. And remember, if you can't, the way to call this function is you'll be using this .vb file in your project. So this declaration has to be there. So if you're coming from a C# background, you have to convert this line to a C#, like a static or a shared functions. So this is the name of the function. So to call that, you have to understand what the function does. Again, most of these functions are very simple and straightforward. Say you want to read the data, so you have to pass the handle. This is the handle that belongs to the WinSCARD programming. So the second parameter is you have to specify how many bytes you want to read, and the third parameter is you have to pass an array which has a size of number of bytes you want to read, and the third parameter is you have to specify from which address you want to read. So this is you need all these things to read the memory card. You have to know the address, you have to know how many bytes you want to read, and you must provide an array to store the data from the card. So if you look at here, I've got OK5422 reader writer, and I'm going to insert a brand new SLE4442 tag. Now I'm going to check for the readers. So you should see this Omni key 5422. As I mentioned before, this is a dual interface card. The first one is the contact and the second one is the contactless. You can see this letter CL. So connect, and you know that this is the screen that works with the standard APDU. We don't want that. Now we want the screen that's written for Sync API. So here we have provided option for which DLL you want to use, whether to use a 64-bit or a 32-bit. Somehow my PC doesn't work with 64-bit. I'm 100% not sure why. So just stick it with the use 32-bit Sync API. So everything what's going to happen is visible in the commands tab. The first thing what we did was to read the entire tag. Now if you look at the commands tab, the software shows the various commands as well as the address and the length, all the information that are passed here except the handle. Now this is something this is some kind of a binary identifier or a structure which you don't have to see that, but these three parameters is what is shown here. So the address is 0 and the length is 256 bytes. So you can see that the first line shows what is the command sent to the reader, not to reader, what's the command used in DLL, and this link, the right arrows shows the data coming from the reader. Now the next thing before you write, you have to authenticate. So you have to understand how the authentication is done. Again, if you go back here, in order to present the pin, so this is the function. It's called scard 2wbp present pin. Here, if you ignore the first parameter, that's the handle, so you're going to pass the pin. So you have to pass, this is fixed to 3 bytes because SLE 4442 needs 3 bytes of pin, and this is an array which has your 3 bytes of data. So this is an array. So you can find out from here, if you come across in LP type, so you're going to pass a LP, so LP bytes, and it's a long pointer byte. You're going to pass an array. So this array must be of size 3 bytes, and this array is where you pass the pin. Again, if you look at the documentation here, you can see that if the pin were correct, you will get OK return message. Otherwise, you will get so it's supposed to say the OK PW wrong. So you just get a random number. It doesn't tell you that how many wrong passwords you have used so far. It doesn't tell, it just tells you now that this is wrong. Now going back to software, this is a brand new tag. The pin is all FFs. If you now hit authenticate, you can see what has happened here. The command uses a card W pin, present WP present pin. The length is 3 and the data, this pin is what it is. Now after that we are going to do some write operations. So I'm going to fill with all 0 and hit write. Now to write, again you have to go back to documentation here. So this is the function. So there's 2WBP write data. Now here it's very obvious. To write the data, you have to tell from which address you want to write, what's the length of the data you want to write, and the actual data itself. So this will be an integer, this will be an array full of data you want to write, and this is the address from where you want to write. And also you will get a OK if it's successful, otherwise an error. So going back here, so we have returned that already. If you see what's happened here, the software user function, what we just saw, the write data function, the address is 32 because our data, starting data is address 32, and this is the data, 16% data that's sent. So now we know how to write. So next thing is to read the protected data. So if I hit this read button, so this is a brand new tag, so none of the bytes are locked. If you go to documentation and look for read protection memory, so here, so you got a handle, you got how many bytes, in this SLE4442 there are 4 bytes of protected memory, and this parameter is your array of size 4, and the data you get is encoded, so you have to follow this. So you get 4 bytes of data from the card, but here the first bit is so I have to give you some more information about this, the way the data is stored. Take for example the byte 1. So in the byte 1 you got 8 bits. So your program is going to get this byte 1. Now this bit, the least significant bit, this corresponds to the address 0, and this corresponds to address 1, and this corresponds to the address 7. And also if the bit is 0, it means it's locked. If the bit is 1, it means it is not locked. And keep in mind, in SLE4442 the default memory content is all bits set to 1 1. So anything, the write will happen only when the bit is 0. So to keep this in mind. Okay, so this byte, what you get from this method call, the least significant bit corresponds to the lowest address. So in the byte 2, the least significant bit corresponds to the byte 8, and it depends on how the Omni key developers have numbered this thing, but what I mentioned now, that's how it works. So the next thing I'm going to show you how to protect the memory. So assume that I want to protect, I'm going to write something before I protect. So assume that we have changed say from 60, assume that for some reason we want all these bits from 16, address 1632, we want all the bits to be set to 0. I want that 0 and I want to log that. So first thing, before you protect, which I mentioned in my previous video, you have to write, and if the write is successful, you can see this is the write command. The write is successful. I want to protect all, so just choose all the bits from 16. Okay, so I've selected the address 16 to 31. I want to protect them. Say write. Now we have seen this warning before. Say yes. Now if you go and look at the documentation first, now there is a command called compare and protect. So in order to protect a memory byte, you have to send two pieces of information: the data to compare and the address. Now what the card does is, if the data matches with the data stored at this address in the card, the bit is locked. So if it's already locked, you will not get an error. However, in this 5422, the one I'm using here, so if you try to lock an already locked memory byte, it gives an error. You just have to ignore the error. So the same command, if you try on a world reader like 3021 or 3121, you will not get any error message. So if you go and look at here, so you can only lock 1 byte at a time. So that's the reason, in order to lock 16 bytes, I have sent this in a 16 times the same command, but with different data. So here the first command has got address 16, data 0, address 17, data 0. We can try to log something with the, let's again, if you read back, you get this. So let's see what happens, what happens if the data doesn't match. Assume that, so I'm going to set this to 0 and I want to lock this address 15. So first I'm going to remove all these locks, reset, and I'm going to say 15, this one I'm going to take. Now see what is the condition we have here. The software has a data 00 which is not returned to the card. The card has the data FF. So if you try to write now, so we got, somehow you got this error protection, it says true. So you have to be careful with that. Okay, so somehow the card is saying, it is okay, it is the compare and protect successful. However, sorry, it is software. Okay, so what's happened here is, okay, the software, even though I have written 000 here, the software still takes the original value. So probably that could be a bug. Okay, the next thing is how to change the password here, how to change the pin. Now to change the pin, there is a command. So that is change pin command. Now this command takes, you have to send the old pin length, which is a 3, and you have to send the old pin. You have to send the new pin length. The old pin is a old password, that's 3 bytes. The new pin length again is 3, and the new password. So in order to change the password, you have to send both the old password and the new password. So again, it's clearly mentioned here. Now I'm going to change the password to, so just change from FF to F0, F1 and F2. So I'm going to hit this change, and there's a warning here that reminds you to remember this password. Say yes, the password code is changed. If you look at the logs, so the command WP change pin is used. The old password is set to, the old password is sent, as well as the new password. And keep in mind, the order of the byte that's sent. Now here the protection, or the protection memory, it has got 4 bytes internally. The first byte is the number of errors, and the remaining 3 bytes, this is the actual password. So this is the lower address. You have to send the lower address first. So that's the reason why you see F2 is sent first. Now everywhere in most of this command, if it's a success, you get a 0, if you can see here. Now I'll show you now one command that can return error, that returns error. So to do that, what I'm going to do is we'll try to write without authentication. I'm going to take out the card and put back again, say connect. So I'm going to read. So let's try to change, say edit this, change all to 1, and I'm going to write. So you got an error, write that error. This is the error from the software, but the actual error, the return error code is this one. Now if you remember, I showed you a couple of header files in the folder. So if you see the header files now, there you can find these wordings there. So this is the error we received from the DLL, and this is what the error description says. So probably now you can show that the password is wrong. Now I'm going to authenticate. If I remember the password, that's F0, F1, and F2. So authenticate, yeah. And now if you write, see the write is successful. Now one more command which is available in your in this DLL is the pin is present. So this command, I don't know how far this is going to be useful. So this command returns whether you have already authenticated with your pin. This command tells you whether the pin is already sent to the card or not. Now this, because we already authenticated, if you say check, you get this, and this is a message, pin is presented. If you see the command structure, there's nothing there. And so if you look at the documentation, there's no yeah, there is a see, the first one is a handle, and you have to send a boolean variable, okay, which is in the output. So the boolean variable get modified to either 0 if it's not present or 1 if it's present. So in order to understand how this thing works, I'm going to take this card again and put it back, connect, go to this, and now check. You can see that the DLL says the pin is not presented. So now if you authenticate, authenticate and say check, you get it. Okay. Now there is one button here that says read error count. Now if you see the documentation of 5422, so when the password entered is wrong, you will get the number of errors that has occurred so far. SLE 4442 allows you to make only 3 wrong passwords. Now if you hit this error, read error counter, there is a error message here. If you look at that, this is the error message said, unable to find entry point SCAR2WP read error counter in DLL SCAR sync. Okay. Now the reason is, so I just found there is a function. So if you look at probably in the initial part of the documentation, it is over here. So it says this is a very good command to have in the DLL. So this should return you how many wrong error counter the card has got now. However, I can see that this function is not present in the DLL. However, it is present in this documentation. So it's possible because the documentation maybe is old or the DLL is old. Okay, we don't know which one is old. So the one more thing I would like to show before I finish. If you use this use 64-bit sync and click, say for example, read entire tag, the software says the read has failed. So the reason for that is, so this card is not present in the, so what the software probably must be doing is, and if you look at this documentation, in order to read, so I think the software is using this command, and on my laptop this SCART sync x64 DL is not present. That could be the reason. So as I mentioned before, it doesn't matter whether I use this or that. So because we want to read and write to SLE 442 tag, so just stick with the 32-bit sync. So that should work. Okay, now it works. Okay, so I hope this video has given you enough information about a sync API, and I think now you'll be in a position to use this concept in your program. Thanks for watching.